Welcome, everyone, to this Professional Development Hour presentation brought to you proudly by the Atlanta Metro chapter of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. Before we begin, we'd like to let you know that any opinions presented tonight are solely the opinions of the presenter and not that of the Georgia Society of Professional Engineers, the National Society of Professional Engineers, or any other of its affiliates. We certainly hope you will enjoy tonight's presentation, so sit back and relax, and on with the show.
So good evening, folks. This is September 11th, 2023. It's been 22 years since the great tragedy of our lifetime. 22 years since that great tragedy. It's appropriate that we have a discussion tonight on how terrorism changed engineering. We have a panel of distinguished experts in their fields. One, a close friend of mine, Ed Carlsen, retiree from Georgia Power. We have John Gonzalez, likewise a retiree from Georgia Power, a structural engineer. We also have Andy Green, who is on the faculty of KSU. And we have Simon. So if you gentlemen don't mind taking a seat, Simon is expertise in engineering, in fire protection, and also lived in an environment that regularly dealt with terrorist attacks, the Irish Troubles.
Just in case you forget my name. All right. Apologies, bit late. Yeah.
Where do you want them to?
Any particular?
Simon Gonzalez. Hey, Andy Green. It's me, Andy.
Hey, Ed Carlsen.
Hey, Ed.
Cozy here.
Yeah.
So, Ed, would you like to give a bit of a background of yourself?
Sure, I can. Again, my name is Ed Carlsen. I worked for Georgia Power for almost 40 years. Relative to tonight's discussion, I was the manager of the transmission maintenance organization for Metro Atlanta in 1996 when the Olympics were here. So there were things that we wanted to make sure we didn't have terroristic acts and things that. In 2001, on 9/11, I was the manager of the underground power system that feeds downtown Atlanta. It's called the Network Underground System, very high reliability, concrete encased duct, redundancy, also feeds the Atlanta airport and other areas in the state. So I was on duty that day at 9/11, so I can talk a little bit about that. Again, I've worked in generation, transmission, distribution, operations, mostly. Spent some time in my last part of my career in a corporate organization.
John Gonzalez. My undergraduate degree was from the University of Pittsburgh, hydrology and hydraulics. I did my master's at Georgia Tech in structural engineering. And most recently, I was an employee for Southern Company, and I retired there in 2018. And I worked in their engineering department and worked on a lot of major projects, including the SCR projects at Barry and Gaston, and also a number of retrofit projects. And I currently still work for Southern Company, but now I'm sort of a contract engineer, and I do work at Plant Calhoun, Plant Bowen, Central Alabama, Generating Station, National Carbon Capture Center, and so I still stay pretty active. And I can share some experiences about what we did during 9/11 when I was a field engineer and I was working at Plant Bowen.
Thanks. Hi, everyone. I'm Simon Goodhead. I'm not from around here, as you may be able to tell. My undergraduate degree is in fire science from the University of Leeds. That was primarily fire and explosion, chemistry and physics, structural response, things like that. And then moved over to Atlanta in 2007. Got my master's in business from University of Georgia. So I help a lot of engineering firms around the country with their business of engineering. A lot of the history and background from my undergraduate degree goes back to 1605 with the gunpowder plot, which was the gunpowder under the Houses of Parliament, through the Fire of London, and then all the way up to kind of some of the structural steel response during 9/11, and the rebuild of Manchester following the 1996 bombing by the IRA.
Good evening, everyone. My name is Andy Green. I'm an assistant professor of information security and assurance at Kennesaw State University in Kennesaw. I am the degree program coordinator for our Bachelor of Business Administration in Information Security and Assurance. Broadly speaking, my research interests are in the confluence of security, privacy, and public policy. And probably one of the many things that, let's face it, with cyber being so hot, I could talk about any number of things and it would be relevant tonight. But I think probably given the occasion that we're all here for, I'll be happy to talk about the exponential growth of data capture by governments across the globe, what that means for us as citizens, how is that data being used, how is it being stolen, and some things that we need to be concerned about. And I appreciate the invitation and thank you all for having me here.
The first question posed was, in particular, where were you when the first plane hit? Were you watching it live like many people?
So before I pivoted to academia, I actually worked a legitimate career for a living. And at that point in time, I was working for a medical transcription company. And I was doing software interface development to move data back and forth between our branches to hospitals. So I was on the way into work that day, just like any other day. My stepdad at the time was a commercial airline pilot. And so I'm in the car and I'm listening to the radio and I hear that a plane has hit the tower. And my mom knows that when I call and say, "Where is Dave?" something bad has happened. And so fortunately, thank God, he was home, and I was talking with him as the second plane went into the second tower, and we both said at the same time, terrorists. So I went on into work, and obviously nothing got done that day. We were all huddled in a conference room with a TV fired up, trying to figure out what was happening, and more importantly, what was going to happen next. It was an interesting day, to be sure.
So I'm a lot younger than I look, and I was actually at university studying fire and explosion science. It was early afternoon in England, and when the TV coverage came on, the first plane had already hit, and there was a couple of things which were particularly noteworthy between me and some of my peer students related to the size of the fire, the size of the impact, the location of the impact, and having grown up with, not great things happening around you on a year-to-year basis, it was pretty clear that it wasn't an accident. When the second one hit, obviously that confirmed it. But what was interesting, and probably some of the structural engineers in the room maybe already had the read, there was not a scientific reason why the towers would not come down at a very early stage. And there's lots of reasons behind that, which, if anybody wants to talk about later, we can talk about. But that was very much the case from our perspective. Watching it, we were just watching our clocks, our watches, and waiting.
So I had the unique, pleasure of working as a field engineer at Plant Bowen in Cartersville, Georgia, at the time that the first tower was hit. And I remember arriving at the security gate, and the guard, which was rare, ignored me and was staring up at his TV, and I kept wondering why I couldn't get his attention. And then I noticed he was looking up at a little black and white TV that he had, and I watched in horror as I saw the plane hit the building, and it kept showing it and doing the replays. And I asked him, "Is this real?" And he was just shaking his head in disbelief. After I entered the plant, the first thing I did was I went to the trailers that we had and tried to log in. Well, it took me probably 20 or 30 minutes to log in because everybody else was doing the same thing. We were all trying to log in and find out what had happened. Interestingly enough, I don't know if you realize this or not, but one building went down in 40 minutes. Another building went down in 70 minutes. And if you think about it, there were people that were trapped in some of those floors, up 75, 85 floors, and trying to make their way down. And all the while, in the dark in most cases, water pouring down the steps of the World Trade Center. And it was amazing that they got as many people as they did out. But I'll never forget that, because the very next day I arrived at the plant, we probably had over a dozen guards up on the roof with shotguns, and they had declared the plant a no-fly zone. So we were taking it very seriously.
As I mentioned, at the time I was the manager of the Network Underground system, there was a new Georgia Power VP that had come to visit with me that day, and I was trying to show her, so she was going to spend about a half a day to get familiar with that. So I had taken her out in the field, so we were kind of going around showing her some of the facilities, explaining what Network Underground was all about when the first plane hit. So my engineers and operators called me, just said, "Hey, something's going on here, and then you might want to keep an eye out for things." And then when the second plane hit, they let me know what was going on. So we immediately went back to our control center, watching things going on. And then I forget the timing on the Pentagon. The Pentagon was hit. So we're saying, what are targets? And there was a lot of discussion that large, tall buildings in the city of Atlanta may be targets. So all across the city, things were locking down. We called our crews back in. I happened to have crews working at the CNN Center that day. Now, the CNN Center had locked down their whole facility. So my crews were stuck inside the CNN Center. They could not get out. And there was some concern that they were going to be a target. Something like CNN might be a target. So it was a stressful day and morning as things evolved. A lot of unknowns. If you think back, nobody knew what was going on. And again, the big concern was, would someplace like Atlanta be another target? So there was a lot of conversation, and in the following days it was just continuing that.
Traditionally, most engineers don't worry about people destroying what they work on. We worry about not understanding the physics and having an accident, be it poor design or maintenance or deterioration or adverse weather conditions. What's your reaction to the environment that changed, either false positives or false negatives, that someone may be attacking what engineers do?
So obviously I'm not an engineer, and I did not stay on a Holiday Inn Express last night, so I have no opinion on that aspect of the question. What I will share with you is, from a cyber perspective, welcome to our world. Because from a cyber perspective, I worry every day about what threat actors are going to do against our networks. And so while we are a nascent discipline in terms of length of years that we've had the cybersecurity moniker as a professional title, right? We're not engineers, we're not doctors, right? We're none of that have got hundreds of years of formalization to an extent of what you expect from your degree and your discipline. We don't know what we don't know, and what complicates it for us is that the threat landscape shifts every day. And so things that we need to protect against today, we weren't even thinking about them 5 years ago, unless you're somebody like me who your mind is oriented in that direction anyway. I naturally lean offensive. I naturally lean forward. I naturally think, all right, I know what that thing is supposed to do. I'm going to figure out how I can make it do what I want it to do. for us having that mindset and working with that mindset, we're still infants. And so when we think about the world and how it shifted, right, like I said, we say, welcome to our world, because we think in terms of threat models. We think in terms of how can this be taken advantage of. And it was a wake-up call for, I would suspect, the engineering discipline, although I don't know that for sure, but I would suspect that day was a wake-up call for engineers to start thinking in terms of threat modeling, not against the environment, right? We were having a conversation earlier, different regions of the country, how to build a roof to protect against snow, right? How to build to protect against earthquakes, right? We generally don't think the worst of our fellow human beings collectively. I know I do some days, but collectively we don't. And so to think that we need to threat model an environment where a building can be attacked by a human being flying the plane scares the hell out of people to even have that thought. But that's where we are. And so it's the biggest thing from an engineering perspective that I could see is understanding that ordinary everyday tools in this context can be used against us, right? But that's where we are from my perspective.
I'd actually be really interested to get your thoughts on how cybersecurity and the power network kind of come together, but that may be an entire conversation.
We're going for a pint after.
Okay, that's fine. So from the fire forensics from the World Trade Center, the second World Trade Center attack, was particularly interesting. 1993, there were some lessons learned from an egress and a fire safety standpoint, insofar as people kept flashlights in the drawers of their desks because they knew that the power could go out in the staircases. That was a very handy piece of information to have in 9/11, 2001, because the lights went out in the staircases. So we knew that it was a problem. It was not something that had necessarily been addressed to the standard to create some robustness. You wouldn't necessarily have expected it to be an aircraft. It could have been a significant fire. But it could have, we designed for those circumstances. What was perhaps more interesting was the age of the fireproofing that was stuck to the steel. The glue, the adhesive, since the time of construction, had essentially disintegrated into nothing. And you could write your name in the steel. In fact, there's a number of buildings in downtown Atlanta, you mentioned that earlier, where I have written my initials in the fireproofing to prove that the fireproofing needed to be replaced. Now, the consequence of that from an engineering standpoint was we changed the parameters for the cohesive force for fireproofing on steel. Up to a certain height building, it's one number. If you go beyond that, so super tall building, it's a different number. Are those the correct numbers? We don't know. But it's going to change the behavior of the building given the potential threat of the target. Now, perhaps the biggest challenge from the engineering industry, from the built environment standpoint, is that the results from the World Trade Center, fire investigations, and things like that were published in 2004, 2005, but they did not make their way into the standardized codes in the United States until 2009, and in many jurisdictions weren't even adopted until 2010, 2011. So we are designing to standards and codes which are 10 years out of date, and that has continued to be the case and will always be the case with this type of code structure. Very interesting. Can you design for everything? Yes, absolutely. Will you financially be able to pay for that to be built? No. So at what point do we allow terrorism and terroristic acts to define the standards of safety, meaning that we're no longer able to produce and build the buildings at a standard of care that's appropriate for the public at large and is financially responsible to the clients and the people who are looking to build it? That's a big question.
Well, no doubt about it. I think one of the things that we look at today are connections and how they failed during 9/11, I think one of the things that those connections were exposed to, and no one was aware of it, was all the fuel from the planes. The fuels added tremendous heat to the connections, and the fire just, continued to blaze until finally some of those connections failed. And as they failed and those slabs started to come down, you had that pancake effect, and it just got worse. It was almost like a zipper effect in essence when those slabs started to come down. And unfortunately, I don't think those buildings were ever designed to handle those kind of loads. It was amazing that the building itself didn't tip over. So in some respect, maybe the bracing and what have you was good enough to hold the building in place, even though there was a lot of damage done to the building itself, and obviously a lot of life lost. But unfortunately, I don't know how you design for those kinds of temperatures and what they experienced on that day.
Let me take it to a higher level on a power system. There's key components, design components in that you want the system to be as reliable as possible. That's an inherent design system. So it's got to be able to withstand equipment failures and weather. And the Southeast, we get all kinds of weather. Ice storms, tornadoes, hurricanes, you name it. We don't get earthquakes like out west, but we get just about everything else. So inherently, we're already designing. Another buzzword in the utility word is resiliency. So it says, if something happens, how does the system respond? So you have things like redundancy, like this network underground system I mentioned is called an N-1 system, that you can have one of the components fail and you still have full capacity and full ability to serve power, and you don't lose power. So you have that redundancy, you have reliability, you have resiliency, and then you're factoring in things like safety of the public, safety of the workers, and it's got to be cost effective, as mentioned here, and economical, and it has to be maintainable too. So that all goes into the design. So the terrorism aspect kind of just adds a little incremental bit to a power system, because you're already designing the system to handle a lot of catastrophes already. So it's not a drastic change, but it definitely implemented some changes. On a power system, we've dealt with more vandalism type things for years. Hunters love to shoot the insulators that are on transmission lines, things like that. And we've had vandalism where people shoot at power transformers and drain the oil out of them. So those kind of things have happened in the past, but they were more in the category of vandalism. Terrorism's a little different thought process, and I can talk maybe a little later about some of the thought process that went in preparing for the Olympics, and what did we do special with either to make sure the power stayed on, and we did have some terrorism type components that went into some of the planning that we did for the Olympics and then post 9/11.
9/11, Oklahoma City, they provided a focus on building vulnerability. Had there been a history of building collapse during fire before, high-rise building collapse?
The collapse of buildings is pretty common. You can start from small scale, right? So 1666, you got the Great Fire of London, took out a big chunk of London. That happened then several times here in the United States. New York, Chicago, San Francisco all had major fires, the consequences of which were to rebuild the cities in a way which were more resilient. You heard the term fireproof probably thrown around in the early 1800s to the late 1800s. Strangely enough, that doesn't mean anything other than some of the components were non-combustible. That's great, buildings still burn. When it comes to progressive collapse and the failure of structures, especially high-rises, a common feature, and you actually saw this in a Madrid fire in the mid-2000s, there's a pretty significant fire. It wasn't sprinkler controlled. It caused the failure of the steel. Typically, when we look at steel failure, we're looking at temperatures, if I can speak in metric and then I'll convert it, 500 degrees centigrade, so about 1,000 degrees Fahrenheit. We start to see a pretty significant loss of strength of steel. Where those joints occur, you'll see crumpling of the columns, you see deflection of the primary beams, you may even see deflection of the secondary beams and the joints. Once we start to get to fuel temperatures, right, you mentioned in 9/11, those fuels burn typically around 1500 to 2000 degrees centigrade, so about 3000 degrees Fahrenheit. We suddenly have a very different fuel load compared to what we test using standardized tests. Some of you may be familiar with ASTM. E119 has a time temperature curve. It tells us how hot a furnace needs to be over what period of time to achieve what specific strength resilience of the steel or the concrete structure. When you have temperatures or fuels which far exceed that time temperature curve, it doesn't matter what you protect it with, you're going to end up having a much shorter duration of steel strength. The Madrid fire burnt very similarly in many ways to Building 7, where it was a long duration fire. It was pretty hot, and eventually the steel failed. But the building had been designed to prevent progressive collapse and had secondary supplemental structural improvements that stopped the building pancaking all the way to the ground. I think it lost something like 3 or 4 floors and it stopped. The building still had to be demolished, right? But it did not cause complete failure in the same way that you saw with the World Trade Center. The World Trade Center buildings also had a very different structural configuration than many other buildings and high-rises up to that point, which allowed it to get to that height. And so you've got to think about all the different components that feed into these types of things. Now we have impact resistance for buildings over 420 feet. That impact resistance is around the core. That's intended to try and protect the staircases. We also have things like wider staircases to allow contraflow, so the fire department can go up against the flow of people coming out. I can also go into a very deep level about human behavior in fire, but what we saw in the World Trade Center is pretty typical. People kept their head. They stayed focused on the primary objective. Yes, there were too many people in the staircases. Yes, it slowed down the flow. Yes, the lights were out, but people kept relatively calm and focused on their primary objective, which was to leave the building. And those types of things, if you think about how aware they must have been about what was going on around them and how potentially adverse their situation was, to be able to keep that level of calm was really quite remarkable.
So we focus pretty much on buildings. That's not the only risk areas. Any comment about what would be for our whole society, the biggest risk, the biggest source of the risk?
These two. Cyber attack on power infrastructure.
Yeah, so I'll use a few examples. Like I said, the 96 Olympics, we had an edict from our executives, the power will not go out, period, whatever it takes. So we, a year beforehand, started maintenance on equipment, things of that nature, checking. And another aspect of is you may not be able to prevent some things, and we did some things to prevent. We had plans where we had security people at substations, we had patrols of transmission lines, we did some hardening of infrastructure. I can't remember, I'm getting my things mixed up, but for instance, the underground system in downtown Atlanta, you have manholes where your cables are. So things like locking the manhole cover so you couldn't get in there. We didn't put up walls around the substations, but we had some systems. And there were lots of, I'll call them snake oil salesmen at the time, coming with all these great systems. So we did purchase one on one of our key substations that was it's supposed to be an intrusion detection system, and you put it around the perimeter on the chain link fence. Well, every time the wind blew, we got an intrusion detection. So it didn't quite work as well.
Physical idea?
Physical, yeah. So anyway, and that was 96. But the key was a lot of planning to say if something happened, what was your response? You know, if you had an event and we had looked at some additional redundancy on certain systems and things of that nature. I'll give a little story here. We had contract security people at a lot of our key substations that either fed a venue or key transmission stations. We had one of these contract security folks call in and said, there's been an explosion at a large transmission substation on the north side of town. I wasn't on duty. We were working 12-hour shifts, but I lived like 5 miles away from this substation. So I got a call and said, hey, we've had a report of an explosion there. So we're thinking, okay, what's going on? We had the security guard there. I got over there about the same time our Georgia Power security folks got there, and the guy who was there was shaking. And he said, man, there was just this huge explosion, and his quote to me was, I thought I was going to see Jesus. So what had happened, though, it was just an equipment failure. It was a 500 kV lightning arrestor, which is about a 10-foot tall device. It just failed, and the way those things fail is a catastrophic explosion when they fail. So, you know, there was a lot of eyebrows raised. Did we have some terroristic act? But it wasn't. But it was an explosion and things of that nature. So, again, the thing is planning for this stuff, trying to do what you can to mitigate the problem, to keep it from happening, but as well, response is a key component.
Yeah, from a structural standpoint, you know, we can go out there and design blast-resistant buildings. Most owners are not going to pay for that. There are only certain buildings where they'll be able to afford to even consider that. Oftentimes, we look at maybe adding bollards, adding more security, looking for different ways to engineer the potential for threat out of it. But sure, we can add shear walls, we can add more braced frames, but in the final analysis, we're going to need a lot more help from our other partners to keep those buildings safe. I think some of the federal buildings may be designed to be blast resistant, but some of the older ones probably aren't. So there's some limitations to that as well. But we're adding more bollards wherever we can. In fact, you probably see bollards being used even at the malls because they've had all these smash and break-ins, and so they're putting bollards wherever they can to protect the buildings and to protect the people. And unfortunately, we can't avoid it. There's going to be homegrown terrorism. So.
Yeah, a lot of times you see them as planters, so they look pretty. You ever wonder why the planter's outside the hotel? That's why.
So we've hit on a couple of different topics here, and I think from a cyber perspective, right? I teach this phrase to my kids all the time: plans are useless, but planning is essential. And so in the cyberspace, we talk about incident response planning. We talk about disaster recovery planning and how to do that. And it's easy to put a document together. It's easy to put a group of heads in the room and say, here's our plan. Mentioned cost earlier about we can engineer the hell out of these buildings, evidently, from a physical perspective to protect everything, right? But it's cost prohibitive. Mm-hmm. And the ugly conversation that nobody wants to ever have when we get to this point, and we see this in cyber as well, is effectively you're putting a dollar cost on a human life. Yep. And nobody wants to talk about that. Nobody wants to think about it in those terms. But when I go, when I do outside consulting work with firms, and I ask them, all right, what do you want for me to do? Well, we don't have a security function, so we want you to help us stand one up. No problem. Come to them with a preliminary thumbnail sketch based on conversations, and what's the first question I'm always asked?
How much is it?
Bingo, right? And so everything is a trade-off. It's an evaluation. To be cold-hearted about it, it is somebody in a room somewhere with a spreadsheet and a formula that helps inform the decisions being made by the firm leadership, the executives in the C-suite. Their priorities are different than those of us on the front line working. And that's not to say it's right or it's wrong, but when kids are coming through my degree program, they're all gung-ho. They're like, we're going to secure all the things. We're going to lock down all the servers. We're going to protect all the networks. I say, that's great. What happens if a fix that you put into place interferes with Bernice in payroll being able to get everybody paid? And I tell them, you can do whatever you want to on your last day of work. Yep. And that's when they get hit with the cold reality of, they don't care about security? No, they care about being profitable. That's what firms do. That's why they're there. And so the philosophy that I try and share with my kids is, you don't get to say no. Right? When the boss comes in and says, I want to do something that from an architectural or design perspective, is horribly insecure, you don't get to say no. Well, I mean, you do, again, if it's your last day at work, right? Our mentality has to be, yes, and how can I protect as much as possible given the circumstances that I'm in, right? And so we go to purchasing the physical IDS where the wind blows and it fires. We've got network intrusion detection and prevention systems, IDPSs, right? They're all the rage. Everybody says this is great until you get your 45,000th false positive in 4 hours and you're the poor dude or dudette on call duty having to deal with that, right? They're wonderful until you have to implement them and tune them and use them. But the key here is that we're all talking also about defense in depth, right? The physical IDS fails. You've got the physical guards there who are putting eyes on things. We're monitoring networks, right? And if you're forward leaning, you're getting now the one of the big hot areas is threat intel. Firms think that if they just listen closely enough, we can hear the threat coming. Well, that's great, but if your network is wide open and leaks like a sieve, who cares, right? But again, the snake oil salesmen come in, threat intel, we're going to tell you about the bad guys before they get to you. A, you're lying. B, you're a well-paid liar because they're selling that stuff at a premium, right? And C, it's an example of people trying to learn how to run before they walk. I'm all about threat intel. As long as you've proven to me that you've protected your network, you know where your assets are, you've done an analysis of which portions of your network actually contain higher value than others. It's okay to prioritize things. This asset is more important than that asset. And that's where we direct our spend. But firms don't do that in cyber. But they're going to buy the new hotness. They're going to buy the IDS from 5 years ago. They're going to buy the threat intel feed that's custom built and proprietary. 2 words that should always scare the hell out of everybody, anywhere and everywhere, right? But we'll buy it because we think it shows from firm leadership. It shows, well, we're doing our due diligence. No, your due diligence was to have the resources in place to defend and protect your network. And when we develop a plan, incident response plan, how do we train on it? Do we train on it? Right? Try and get a group of executives around a table for a tabletop exercise. Good luck. Do the dollar cost calculation on what it costs to have each one of those heads and their 2 or 3 admins who come with their entourage in that room along with the professional there to conduct the training exercise. That's a soft cost, right? But they're not going to want to do it. And then if they get exposed not knowing what they're doing during the tabletop exercise, there's the political embarrassment that they have to face as well. And they didn't get into the C-suite by being dummies, most times, right? And so they're going to avoid those things. So the very things that we need them to do, they're not going to do for either political or financial reasons. And it's where we are. I don't know what else to say.
You've touched on some complexities of a failure. Just take, for example, Surfside collapse. Wasn't terrorism, but the cause of it seems to be wrapped up in different complexities. You throw in cyber complexities, you throw in structural complexities, you throw in infrastructure complexities, and yet professional engineers are rooted in this concept of sole responsibility. And so, how do you address problems of assigning sole responsibility on complex overlapping areas?
I can touch that from cyber. Nobody wants to own anything, right? When we do a risk assessment on a situation and we go to the asset's owner, right, whoever that is functionally within the firm, and we say, here's your risk, here's what we think it's going to cost to remediate it. Their favorite phrase in the world is, I accept the risk. They love to say that right up until the point in time where we say, no problem, please sign this document. Well, wait, what does this document say? It says you're accepting the risk. Oh, I can't sign that. I got to run that through legal. No, it's been vetted by legal. We did this because we knew you were going to say that before we came in the room. Legal signed off on it. It's fine. Please sign that document. And then that goes into my supposedly fireproof safe, right? So that when things go to hell in a handbasket, and that executive is trying to say, I didn't know anything about it. Here's your get out of jail free card. Unfortunately, that's the way it works. But finding ownership, especially with risk management from a cyber perspective, everybody's eager to say, I just accept the risk, because they're not going to be held accountable for it long term, right? We all know that that's largely a myth. Or they're going to say, well, we have cyber insurance. That's also the new hotness. Threat intel and cyber insurance. We can just insure all the things and we're fine. No, that's not how it works. Insuring cyber assets is completely different than the physical realm, as we're discovering. Early entrants into the cyber insurance space have, what's the polite way to say it, lost their shorts? We'll go with that. They've lost their shorts because they had to pay claims that they were not prepared to pay. And so assigning responsibility, assigning accountability, and actually holding people responsible for that, that is the big thing. And it's not easy. And especially in cyber, we see chief information security officers or CISOs with an average lifespan of 18 months. They get hit, they golden parachute out, they take a couple of months off, they land a CISO gig somewhere else, wash, rinse, repeat. That's what we're seeing.
Just a moment.
I want to follow up on, I'm the one who asked the question about sole responsible charge, which is an engineering concept that says that there is a person up there in any large engineering project who supposedly knows all of the aspects of it, at least at some level.
They put their stamp on it.
And I want to mention an example that has to do with the university system of Georgia. You'll appreciate this.
My comments are my own and are in no way affiliated, and seriously, I should have said this half an hour ago, are in no way associated with Kennesaw State University or the University System of Georgia. Please proceed, sir.
Okay. So, I'm at a system-wide demonstration of the new learning management system being conducted by people at the University of Georgia via the data center that's about 7 miles away down on something Bridge Road outside of Athens on a Saturday morning, and the whole thing goes dead as a doornail. And guess why? Well, they have fully redundant fiber optic cable going from the University of Georgia to the data center where this thing is. They didn't tell the people who were physically installing the fiber optic cable that the redundant cables needed to go on separate paths. So they're in the same conduit. And a guy with a backhoe dug it up. Okay? Now, that sort of thing happens in any huge engineering project because the subsystems are so widely dispersed that there's not somebody in sole responsible charge. How do you get around that?
So what's interesting is that reminds me of when the power went down at Atlanta Airport a few years ago due to a fire in the power supply tunnel where both power supplies were separated by 6 inches in the same tunnel. Within large engineering projects, and I think about, I'm mostly in design and construction rather than infrastructure. The ability for engineers to oversee the work being conducted by the subordinates is mostly achievable where you're at about a 1:6 or a 1:8 ratio, right? At that point, you kind of you know what's going on, you're being asked the questions, you're giving the direction, you're redlining the documentation. Two things have been pretty interesting over the last few years, and I say the last few years, really since around 2015 or 16, as the economy started to get really going after the recession. The time constraints of projects started to get shorter and shorter. And so the same amount of work is being demanded to be done in probably by now half the amount of time. Now that still requires the same iterative process of idea, test the thesis, go through the design process, find that it's wrong, go back to the idea, develop the thesis, advance the design, go and check it out with the rest of the team, find that it's wrong, and go back to the beginning. So that iteration still, in theory, has to happen. Well, now we have a fancy thing called Revit and BIM, right? Three-dimensional plan development. That's lovely. It doesn't stop that process being needed. And so what many architecture and engineering firms are doing is agreeing to the schedule, even when the schedule is not fundamentally feasible. A peer of mine has the phrase, and I don't know if this is appropriate or not for this forum, but 9 women can't make a baby in a month. It still has to go through that same iterative process to get to the end point. Now, with Georgia and other states where subrogation is so unfavorable for us, we find that the policy limits are being hit on multiple lawsuits, and it's easier just to stroke the check by the insurance companies. Now, what's happening across the country, and when I meet with engineering firms and architecture firms across the country, what used to be fine at a $2 million professional liability limit suddenly became 5, and now it's 10. And for small businesses especially, trying to rustle up $10 million professional liability is not an easy thing to do. It also is not easy if your firm is in a single discipline, because you can't demonstrate diversity of your revenue stream and diversity of your project typology to be able to move yourself away from those types of limits. And so there's more and more firms that are either having their requests rejected outright, or the premiums become so expensive they've got to figure out a new business line. You know, drugs is not the answer, to try and generate the revenue to pay for the insurance. But it doesn't stop that sole responsibility component coming to the front. Last point, and I'll pass it on. Florida has an ethics requirement when you go for your engineering license renewal, right? Ethics and morals are required to be studied every year. I think it's like 1 CEU, right? It's not a big ask, but you got to go through that process. I have quite a few licenses, and that's the only one that I can think of where I'm required to do that. And that would be a really good thing to introduce in other jurisdictions as well.
2 on ethics and 2 on laws and rules.
Thank you. Thank you so much. I knew I spent a lot of time doing something last year.
So that reminds me of, I guess, that we go back to the Surfside failure. And one of the first things that we learned was that they were required to go back and re-inspect these buildings, I guess, every 40 years. And I thought, why every 40 years and not why every 15 or 20 years? Well, it turns out, from my understanding, they're one of the few states that has that. And I didn't think it was stringent enough. But in fact, it's probably more than what most states require. And in fact, in the case of that failure, there are a lot of things that led to that failure, one of which was probably fundamentally punching shear. They kept adding loads to that slab where they had the pool. They put planters there, they put tiles there. They continually added loads until finally they had that two-way shear failure. And when they did, all it took was one column to start coming down, and everything came with it. So, failure can happen in so many different ways, and they were so close to the ocean as well that there were so many different ways that building could have failed. But honestly, I think that we've got to look at better ways to regulate how these buildings are inspected. And also, one of the issues they had there was the HOA didn't really want to spend the money to get it updated and repaired, even after the report came back and structural report told them that, hey, you've got some issues down here that need to be addressed. They did want to address them, they just didn't want to address them right away because they were so expensive. So they were taking their time, and unfortunately, time was not in their favor.
Back to your question about a sole owner of something, and you're example of the Atlanta airport. I know a lot about that, most of which I cannot talk about here. But I will say this, this sole ownership is a component there because any meeting that we would have at the airport would require a room about this big, because you have the city of Atlanta, who is the primary owner of the airport. There's another organization called the AATC, that's the Atlanta Airlines Terminal Corporation, that pretty much runs the terminals, and they are funded by the airlines primarily. You have FAA involvement, they have a say-so, and then Georgia Power would be on there, and then a handful of other letter organizations would be in there. So everybody's got some input on these things. So you raise concerns, you raise risks, you raise this, and it's a joint decision of economics and a whole flurry of things that go into there. So there's no sole owner. You've got different players in there that it's a compromise decision or a decision that's made at some level that is there. So that plays into a lot of these things.
One thing that I want to, because Surfside's a good one, the Atlanta airport's a good one. Think of, you probably aren't familiar with Piper Alpha in the North Sea. You are familiar, I'm sure, with Deepwater Horizon in the Gulf. The way to think about, and we can think about the Wyckoff Hotel fire in downtown Atlanta, any major fire that you care to think about. So much of our industry is disaster-led. We learn how to build structures properly from structures falling down. Fortunately, that was from 3,000 or 4,000 years ago. We learned how to design electrical systems, probably by a few people losing some hair and various other functions over the course of the early 1800s. Breathing being one of those, yeah. Fire, right? Fire safety. We took, there was a couple of big fires, but really the turn of the century, we had the New York Shirtwaist Fire. We had several fires occur in Ohio and Kentucky. We had some in Chicago, and we learned things like it's good for the doors to open outwards. It's good to have more than one staircase. But all of those things were disaster-led. In every single major incident that was non-terrorism, the way to think about what happened is have a stick with several slices of Swiss cheese. Call it 7, call it 10, whatever that number is. And turn every one of those pieces of cheese at a slightly different speed on that stick. At some point in the future, you will suddenly have the holes align, and that's when disaster strikes. And every single one of the incidents we've talked about up here, that you've seen out there in society, they've all come down to that simple fact. This had to fail, and this had to fail, and this had to fail, and this had to fail. And that's where we get that disaster.
I've got nothing. That's it.
One of the things I'd like to talk about is how to bring down a city to its knees. Let's take Atlanta. When I moved here shortly, there was a big bad accident on 400. The road was stopped, took people 12 to 16 hours to get downtown. I've thought about that and said, gee, if I wanted to bring this city to its knees, at least back then before you could work virtually, all I had to do was take down Spaghetti Junction, 400 and 285, and I-75 and 285, and that would bring the city to its knees. Nowadays, you can work virtual, so that may not be quite as critical as it used to be. But what's coming up in its place, for example, are self-driving cars. Well, you have a self-driving car, it can keep itself out of trouble. But what they're saying is they're going to go and have each car communicate with each other. So all we need is some bad actor to go and say, hey, I'm going to buy 1 million of the chips that they put in these cars, and I'm going to put about 50 of them at this intersection and 100 of them at that intersection. So everybody's going to think that these cars are not moving at all, and they're going to reroute everybody into all kinds of crazy places. And guess what? is going to bring the city to its knees. How do you prevent somebody who comes up with these kind of crazy scenarios?
A, welcome to my world, right, again. And B, they're not crazy, right? They are happening, right, unfortunately. And so when we look at the most recent event, probably from a cyber perspective that's relevant to us, is when the city of Atlanta was ransomware a few years back. Now, I just happened to be the expert, the reporter who broke the story, Caitlin Ross. We had worked together on some prior things. She calls me at like 8:30 in the morning. Now, academics, like 8:30, it's like, what? Who died? Turns out it was City of Atlanta's infrastructure, as we found out. Caitlin sent me a photograph of that, right? And within 10 minutes, I had identified, just from a photograph of the ransomware message, and I even have a sample of the code, I was able to identify most likely the variant of the ransomware, and then tie to that a likely group of threat actors. You know, hypothetical, right? But, and the city of Atlanta was incredibly quiet about everything related to that. And I did a whole group of interviews about the lack of transparency regarding that. And that's a trade-off, and I get that, right? You don't want to talk about operational aspects of your network, possibly, all right? But you can answer some basic questions, and they were refusing to even do that. The city made the decision to not pay the ransomware, the ransom on the attack. And they effectively burned their infrastructure down to the ground and rebuilt from scratch because it was an opportunity. Now, it cost them more to rebuild than it would to pay the ransom, right? But they made that decision. They needed to do it anyway? They needed to do it anyway, right? And there is speculation as to how the threat actors gained access to their network, and I've seen the data, and I tend to believe that those of us who look at it know how the threat actors got in. But going back to your question of how do I bring a city to its knees, people could get building permits, right? They could not pay their water bill. They could not pay their power bill. Not the power bill, I'm sorry. Could not pay court fines, right? Police officers with laptops in their cruisers could not issue tickets, right? This is what was happening. And how do I bring it down? That may be one way. I may have fun with a power grid section here and there, right? Because at the end of the day, I don't need to bring the entire thing down. I don't need to burn it all to the ground. If my objective truly is fear and terrorism, I need to engage and create enough incidents that get the human factor of fear involved, right? And that's a force multiplier, right? If I hit strategic areas in the city or my target, right? I like that. I'm going to steal that analogy, right? We're spinning the Swiss cheese and we're getting the holes to line up. I don't need them to line up. I need you to think they're lining up. That's interesting. Right? I just need to go through 2 of the holes. That's all. You think the rest of them line up, human beings being what they are, everything is going to burn down. Oh my God, what do I do? And that's how I do it. Allegedly, of course.
I think we also, you haven't really experienced it, I don't think, here too much, but there's 2 types of terrorism as well. There's those that are looking to achieve some secondary motive. In the UK, it was about trying to get the British to leave Ireland. If we think about Black September, it was about recognition for different groups within Israel. When we think about what happened in 9/11, it was just about creating as much carnage as possible, right? And what we know from the 1938 radio transmission of War of the Worlds is the American public will react in a way which is very predictable, which is exactly what you just said. Oh my God, what are we going to do now? Run for the hills. So when you think about it from a city like Atlanta, we already have water constraint, right? Realistically, we don't have enough water for the size of the city. We're doing okay right now, but turn off some of that a little bit. You think about the road infrastructure, right? The fire under I-85 a few years ago shut down that interstate for months. When you think about the internet, right, and the way that the internet serves everybody working from home, could you imagine everybody suddenly needing to go into the office tomorrow? And the other thing is, all of that technology, with respect to the vehicles and the internet, are all reliant on satellites. And so start disrupting the satellite structures, right? Create enough debris in that lower Earth orbit, and you've got a real problem on communications. And so those are the things where I kind of get a little bit twitchy.
A lot of good stuff. Obviously, you knock out an electrical system for a large part of the country for a long period of time, massively disruptive. Yeah. And there are things that can happen. I mean, and especially talking about cyber stuff, and, you know, not too many years ago, in order to get information from a substation, you had to send a man out there and he read an analog meter. Well, now everything's interconnected. So there are real cyber challenges. In 2015, Ukraine's power system got hacked by the Russians. They shut down the system. You can read about it on the internet. So one of the things that is out there in the industry is saying, you've got to recognize that this can happen. So the end user might have to think about that. So water systems, hospitals, things like that, they've got to plan to a certain degree that you're going to be without power for X number of hours or days. So it's down at that end user. And I'll give a little personal example. The GM Doraville plant, which is now torn down, for years they had problems with their robots would go crazy. You know, they start putting red doors on green cars because everything would get out of sync. So they were fed by a transmission substation, and we did all kinds of work to try and manage that. We upgraded things, we put additional lightning protection because lightning would impact them. But as we got deeper into it, we found out what the problem was, is these robots were so sensitive. We could have something happen 100 miles away on the transmission system, and these robots, if you got you went from 120 volts down to 80 volts for 2 cycles, which is milliseconds, the robots would freak out. And there was nothing we could do on the power system to keep that from happening. Lightning occurs, et cetera. So we worked with them closely and said, hey, put some little UPSs on the control systems of the robot, you know, a $200 device, and the problem was solved. And we had spent hundreds of thousands of dollars on the transmission system, but as we got into it, we found different ways. Same thing, VCRs. Everybody in here is old enough to know VCRs and blinking. Well, you put a $5 capacitor, a 5-cent capacitor in there, and the lights don't blink anymore. So the end user device can help. So that has to be a part of the equation, I guess. Not to pass the buck, but that's part of the equation.
It's part of the defense in depth we talked about earlier. It's you know, building all these controls in to help protect everything, right? It's still another layer of protection so that when all else fails, you've got the food on hand, you've got the water on hand, you've got the batteries and the power, so yeah.
All right, gentlemen, really appreciate your taking time this evening, coming out here. Learned a lot. I know that much work's been done. Much work remains to be done. Really appreciate your time. Thank you. And we have a little gift here for you guys. Little gift for.
Thank you very much.
Appreciate that. There you go.
Thanks so much.
Where's the bourbon? I don't.
The parking lot. All right, folks. Couple of more things. We've got the door prize, so I'm going to run my.
We hope you enjoyed this presentation given at one of the Atlanta Metro Chapter meetings of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. To find out more about us or to join us, check us out at gspe.org.